What inspires you most at Sega?
What inspires me most at Sega is knowing that everybody at least interacted with Sega technology once today without even noticing.
We are the embedded experts because we have a solution for every embedded problem.
You can see us as a tool provider for other people that also make products. So if you build a house, you need a hammer, you need a drill. We are that kind of company, but for software engineers.
Debug and trace probes, production tools, embedded software, and software tools. Our vision is to simplify everyday life for engineers and end users.
People using these products are developers all over the world working with embedded systems. Our market-leading J-Link debug probe is the one piece of hardware that you will find on every embedded developer's desk.
Sega technology is inside everything. Space research, medicine, robotics, motorsports. You can find Sega everywhere.
With our technology, I hope we make people's lives better or easier.
My main motivation is seeing all these projects come to life and change the world or improve the world. Sega is the professional home for so many different people.
Developers, makers, engineers.
What unites us all are three words.
It simply works.
So, hello everyone. My name is Paweł Wisnewski. I am coming from embeff, and I would like to talk to you today about some time constraints and how we can integrate it in our CI/CD pipeline and to make it run as regressions. So, first, why real-time constraints are important? There are a few things. If they are not met, bad things happen. One thing can be something get damaged. The machine makes some goods, destroy them, or something like this. In worst case, someone was there and was injured by the machine. And in the bad case, our part of the car doesn't work and someone dies. So that's why those things are important. So what do you need to check time constraints? First, you need to know what you are looking for. What constraints do you need? Depending on your software, on the construction of your software, there are different things. You have some tasks with priorities. You have some resources that are blocked, probably some interrupts or other things. Those all things have influence of how you calculate your deadlines, and they have influence on the execution time. I won't talk about this. If you want to know more, there is a nice book. There's a lot of mathematical things inside. If you like it, read it. I think there's more than 500 pages of mathematics in there. So, but there are also other things. When we know what we are searching for, what is the equation that we need to fulfill, we need inputs. That means we need worst execution time of parts of our software. This is the input. We need to know how long take this function or this task to execute. Then we can put it as a variable into the equation and check if the deadline will be met or not. This is one of the important things. Problem is, usually those things are done late in the software development when you should have a lot of software, and then we try to measure it somehow, and then it doesn't work, and we need to start to optimize it. So, next thing, how do we find out what execution time do we have? So, there is one approach. It looks at your code, counts the cycles without compiling it, just static analysis. It's nice because it's pretty easy. You drop your source code into some kind of software and you get results. Problem is, what about optimization? The software doesn't know exactly. You need to look at the assembly to look at it. And it could be difficult for the software to do it. So the other possibility is to measure runtime. So you start the function and you measure it. There are a few possibilities to do it. One of it is, for example, in Cortex, there is a cycle counter. We can read it, and then we know how long the function was executing. This approach was presented some years ago by my colleague. There is the link if someone is interested. It's in one thing, it's in German. So, but some kind of parts of codes are in C++, so you should be good at it. The other thing is you can measure from outside. For example, toggle a pin, or use some tools that can output the execution time. So, next thing. I have some small example for you. We have two functions. One is calculate, and the second is new value. What they are doing is for calculating the watch time, the execution time doesn't matter, because we want to observe it from outside just to look how long it takes if we can meet, if we are inside our deadline. So, the other thing, for our software, we find out that those are our constraints that we have to fulfill. So, the time that calculate takes plus 2 times set new value should be less than 40 microseconds. It is coming, this 40 microseconds is coming from some kind of requirements that someone wrote, and they measure that, for example, our brake system in the car, from the input to output, it must be maximal this value. We have also the other constraint. It's this one, that the calculate itself should be faster than this value. So, how can we measure it? Any ideas? Tracing, nice thing, yeah. But how will you make tracing automate? Okay, you can use your SQL thing to do it. So, other ideas? Wouldn't it be nice to write it? What? Oh, okay, doesn't work. There. To write something like this. Oh, now it works. Oh, technique. It wasn't tested. It's from Logitech. Okay, I didn't say that. First, those are the two constraints that we have. There are two that we have. Then we benchmark this function with some input. Then we can benchmark the other one with the same input, and then we calculate according to this equation, the combined time, and then we can just try it. Wouldn't it be nice? Yeah, but why we don't do it? So, we can look if it's possible. Someone knows what could be the syntax here. It's almost good syntax for one test framework. Robot, exactly. So, next one. So, we look at the demo. Hopefully this will work. I think it's a little bit too small. Can you read it? Okay. So, as you can see here, this looks very similar to what I have on the slide. First, we are getting some input from somewhere. We do both benchmarks from both functions. Then we calculate combine, and we have should be true, and then we have our condition there. This is the test case that we need, and this works. So one thing that is important in this moment, to calculate worst case execution time, is not to do it for one value. Because depending on what these functions are doing, depending on the values, we could have get different execution time. So for this one, I am using the values sufficient between 0 and 360 with the step of 30. This is what I find out that works. That built it. So now we can run this test. In this moment, the test will be run. It connects to the device that we are developing. It's to make it simple. Because you could implement it on your own, toggle pin, and do it. For this presentation, I'm using the device because it makes life easier. So when we see something doesn't work, something failed, then we can look at it. And we see that at input 60, 90, 150, 180, 210, and so on, those are the values that doesn't fulfill our requirement. And those are usually the problems that you have when you test manually. Because manually you take one value, second value, oh, it works, everything will be okay. But what about all the other values? I could add here and put step of 1 and test all the values that are there. Maybe there are some other picks on some other values. Don't know it. But this is what automation helps you. And this kind of automation, you could run on each commit, for example. You write your function, and then you see how it behaves. One thing that is also possible is if you save the values that we are delivering from the time, you could see, you can save it, put it in some data bank, and later see how the function behave over the time. Because during the development, you might change here, change there, and it can be that on some places, we have this combination of two functions. We have this set value, and we have this calculate. It can be that one function is running really fast, the other is slow. Then at some point of time, we add a little bit of overhead to our fast function, and the condition fails. But actually, this is not the problem. Problem is that the other function was developed, it was bigger and longer, and now the other one is fault because the condition is not met. That's why it's important to have historical data for these things. You shouldn't look at this at one moment in time, you should look at the whole history. So, but how we can fix it? For the controller that we are using there is, for example, we can try to use it with different optimization. You can put O2, build it, and then rerun this test again. We had at this moment, I think 6 errors. Yeah, there are 6 errors. So, different optimization. You can look what compiler is doing. And now we are at only 3 errors. That means optimization helped a little bit at this moment. But this is not the whole fix, because if we push it there, if we do it with higher optimization, maybe with all 3 it will pass. But if you make some changes, it will fail again. So we can do some different things. For example, for this SDK, I am using the Raspberry microcontroller, RP2040 there. They are delivering some floating point operation, SDK, that is extra for this microcontroller. And it is somewhere in the ROM that can be called. And if we run it now, it takes some time because it needs to run this function a few times. And now everything is okay. So the other thing that we can also save here and look at the values. The other one was not meeting the 40 microsecond, and I think with this floating point implementation, we are lower than 10 microseconds for this implementation. So this is how the different library implementation. This is the same for CRC or some other standard algorithms. Can be faster, can be slower, depending on the implementation. We can check it if this one is better or the other one is better. Or when we have some benchmarks for the library, we change the compiler, we can rerun it again and look if something changes, depending on the environment that we need. So who of you is doing real-time systems? Hard real-time? Okay, not so. 3, 4 people maybe. Are you checking your constraints somehow? One maybe, 2 maybes. Automatically, or are you doing it manually at some point in development when you said it's ready? Manually. Putting scope and then measuring toggle pin or something. Okay. Then this is improvement. So, what can I tell you more? You can try to run it. Yeah, and now you can see these are the times that are in local as it should be. Yeah, there are less than 10 microseconds for the compute, and in the total it's this is the wrong one. I need to go one further. Now I have it's about 14 microseconds. So it's this library is about factor 4 faster than the standard implementation from the compiler that is there. So this was it for the demo. Any questions for it? Question or? Yeah.
I can just speak loudly. No, so what you're demonstrating here is actually very interesting because, as you said, it's very important to have the historical data so that you can see at which point, at which commit, things go haywire. But one of the things I feel is lacking in a lot of unit testing frameworks is exactly this. What was runtime combined? Because I know that it was less than my my requirement because it says pass in green and it didn't give a big output. But if it was very, very low and then it suddenly moved to very close to the edge but didn't quite go over, and then a small thing just pushed it.
And you crossed it.
Yeah. Then I don't want to look at the one where it went from green to red.
You want a few back.
I want to see where it went wrong.
Yeah, because usually you have this, it's good, then it's some commit, it goes high, and then and then you have it breaks someone. Yeah.
So does this have it, or should you do that somehow else? For example, log runtime combined, because often you want as little output from a testing framework as possible.
At this moment, this is a robot framework. So as I said before, so it has a lot of different libraries. One possibility would be just you can output at this moment any data to almost any format. It is in Python in the background, so you could write your own library to put it in your time database or something. Only the data that you need. You can also put it inside the log. The logs are XML or JSON. And then when you have all these logs, there are also some Python classes for it, so we can run all the reports from the past through the parser, and then just grab the data that you need. If you know how you log it, you can tag it, and then you can just grab all the logs or last 10 years and just put it through the parser and make some graphics or something like this. And this, it's everything that the robot framework can do. It's everything that you can do in Python, you can do.
So I think what would be interesting as well is to not only see it pass, because right now it measures if something failed, if something got worse. But what would be very interesting too is if something got better. So maybe have something in there that makes it easy to see if I have an improvement compared to previous builds. And then can keep that improvement, for example, and adjust the values. So I can slowly improve maybe to even a better runtime.
Yes, but I think it's not, this one it just runs and you have this snapshot of this exactly state. Then you put it in some kind of database or something, and then you need something that is looking at the data and make this decision. Because this is only test framework. You can use your continuous integration to put some script on top of it and look if the delta is bigger as something, and then you make this, that was better. And you can also observe something like trends. If a trend is going down, it's okay. But if it's going high with the rate of something, then fail it. It would be also possible. But this is also hard. It's something on the top of it. This is only to produce the data, and what you do with this data, it's in your hands.
You use this also in combination with unit testing, so there's the call to do benchmark. Can you get a return value and check it? So
yes.
Basically use it as a combination of unit testing with the speed.
This one.
Ah.
There are two outputs. One output is runtime at this moment, and the other one is the value that is coming out.
Ah, okay.
So we could put somewhere here, log to console, and we can add some variables. Input. This should work. And I start it now. Then you see this for this input we get this output, and it was done in this time.
More questions?
So this focuses on small functions, but do you also have the possibility to see the interaction with other units, so other tasks that interfere with the execution time of one other task?
We are focusing on the one function, because if you have many of them, how you try to schedule it, this will be the problem. How you if you can talk to scheduler, schedule this one at this moment and the other one 1 millisecond later, you can do it. It will be possible because you have access to your software. So you could build it, but it's in your hands. Because there are the different edge cases depending on the operating system that you are using. For example, real-time operating system, if it's possible, could be, but don't have to. It's use case specific. But what is also possible, that is part of what Daniel did in talk, you could test some scenarios like I calculate something on this set new value function that I had. It could, for example, communicate over some bus, for example, CAN bus. And then I could produce traffic on the CAN with some error frames and so on, and look if the error handling, what kind of error time influence had this error handling on my execution, depending on this condition. Because for worst case execution, we need this worst case. So we need error handling that usually can take longer because we try to send this frame few times and so on. So this would be possible to combine it also with the periphery that is trying to communicate with something on the bus.
You had some slide at the beginning about a book with about 500 pages of math about scheduling and things like that. So yeah, real time often has to do with scheduling and things like that. can you actually test that with your framework?
In this book, there are some mathematical things that you can.
Yeah, no, I know. I just wanted to say, okay, the point is real time has to do with scheduling things and priorities and things like that. So you often have a multitask system, and you need to run all those tasks to check your real-time constraints.
This is checking in the runtime. What is in this book is how you do it on the paper. So
yeah, no, but I wanted to know: can you check this on runtime with your framework that this operating system with these priorities and this task actually meets the real-time constraints?
That would be difficult because then it depends on the resources, depends on the inputs, depends on all things that are around. That would be a complex thing. We are focusing in this moment on the single components because this would be a good starting point. Then you have some data that you can work with, because now the tools that are there that I saw, you just calculate something, put 20% on the top, and then this is how it works. So now you can get some real data, and then this is first step. The other one, you need to observe it. I think then tracing would be something like this. You need to put trace on it, a real system, stimulate some input, outputs, and all the stuff, and then evaluate the trace on the end to look if there were some deadlocks or some deadline misses and so on. This is a different kind of testing. One level higher, I would say.
All right, Paweł, thank you very much for your presentation. Thank you very much for sponsoring this conference. With this talk, we're going to close for today. But there are two things that I want to mention. One is not all of you have already picked up a t-shirt from Marie's booth. So if you haven't picked up a t-shirt yet, just make sure to grab one on your way out. If there's still something to eat, well, let's get rid of it. And for all of you that don't quite know how to get to the Volkswagen infotainment place tonight, make sure that you are in front of Bochum Central Station at 6:30 or 6:45. So there's going to be 2 pickups. And there is a question. Yes?
It says comes bakery. So at the stairs for the underground.
Well, yes, just the easiest thing would probably to come outside. Yeah, just right outside of the door that goes in the direction of the city center. Okay, so yeah, that will probably work. I mean, there's going to be a whole bunch of people that will be going there, and I guess right now maybe you have seen some faces already. We will figure that out. Yeah, but just right outside of the door in the direction of city center. And with that, thank you very much, and see you at the party.